Okay, 3 different types of equilibrium you could be asked about. The first one is phase equilibrium. So we said equilibrium is a reaction happening the forward reaction is happening at the same rate as the reverse. So we sometimes, instead of drawing an arrow going this way and an arrow going this way, we just draw like this double-ended arrow to show that both reactions are happening simultaneously. Some reactions only go one way, but most are happening both ways at the same time. So phase equilibrium is about phases, is about solid, liquid, or gas. Okay, so it's about either solid turning into a liquid at the same rate that liquid's turning back into solid, or liquid turning into a gas at the same rate that gas is turning back into a liquid. Okay, so that's another way you can draw it, 2 arrows going opposite directions, or an arrow with the 2 ends. So phase equilibrium, if you're asked about phase equilibrium, you're just looking for something going back and forth, double-sided arrow between just 2 different phases. And this would happen maybe, like I said, an ice cube in water. When would an ice cube in water kind of be at equilibrium where this ice is melting into water at the same rate that the water is freezing into ice? When's that going to happen? Well, only when you're exactly at 0 degrees Celsius, because 0 degrees Celsius is the freezing and melting point of water. It's the exact temperature when water melts and when water freezes. So the thing about phase equilibrium is that it's about phases. It only happens at the melting or freezing point. And again, you need that sealed, closed container. I'm sure that's in here. Here it is. You've got to have a closed container. Okay, so phase equilibrium is about going back and forth between 2 phases. Got to happen at the melting freezing point, like 0. And it's got to be in a closed container again, or it's just going to kind of fly off and you won't get that nice equilibrium. All right, the next one is solution equilibrium. And if you remember from our solution unit, that's a solution is like one thing dissolved in another thing. So like a solid lemonade powder or solid KNO3 dissolved in some liquid solvent like water usually. So solution equilibrium would be like if you put a sugar cube in water, and now instead of having the ice melt at the same rate that the water is freezing, we're talking about the sugar dissolving into little pieces. But wait, this is a saturated solution, so like it can't really take any more sugar. So you're like, well, this shouldn't be able to dissolve. But it does, and the reason it does is because even though some of it is dissolving, for every one little piece that dissolves, another little piece kind of undissolves, precipitates out. All right, so it's an equal, something that was solid and not dissolved is becoming aqueous, but for every one that does that, one that was aqueous dissolves, turns back into solid. So no matter what it is, it's still that same thing. Whatever they ask about, whether it's a phase or a solution, you're still going to say rates are equal, concentrations are constant. Doesn't matter what type it is, but this is solution equilibrium. The only question I could maybe see asked about this is that this is only going to happen in a saturated solution. So this is only going to happen in a nightclub where you're at max capacity. You're only allowed to have 10 people in your nightclub. If you want to let one more in, then you got to send someone out so that one more can come in. All right. So if you want one little piece of sugar to dissolve, you've got to have one little piece of sugar undissolved to be at rate equilibrium. And that's only going to happen when you're already at max capacity. If you weren't at max capacity, already saturated, then it would just all dissolve. All right. So one thing about solution equilibrium is it can only happen in a saturated solution. So it's kind of a factoid that people usually forget. But if you think of the nightclub, I don't know, maybe it'll help. And then the other thing is just chemical equilibrium is just really any chemical reaction like the one I said, H2O becoming H's and O's at the same rate that H and O's are coming H2O. So if you had questions, which one's phase equilibrium? I'm looking for the one that's going back and forth between 2 phases. Which one is solution equilibrium? The one that's going back and forth between being a solid and being a dissolved aqueous. Which one is a chemical equilibrium? The one that's just like a chemical reaction, not talking about